Welcome to the first Actus tutorial. Thank you for joining us in this journey. We hope it will be a profitable journey for you. Actus stands for Algorithmic Contract Types Unified Standards. Or in other words, it is an algorithmic and standardized representation of financial contracts for the analytical use case. Many concepts we are talking about might feel new to you, even if you come from the financial sector. For this reason, it is essential for you to have listened to our so-called UFA lecture, which you will find also on this site. UFA stands for Unified Financial Analysis, and the recordings are the ones from a course given jointly at University of Zurich and ETH Zurich. You have to listen to the first lecture, which covers chapter 1 and 2 of the book Unified Financial Analysis, which you see here. It's published by Wiley. Ideally, you listen first to the lectures and then read the chapters of the book, which I have been told is the easiest way to understand the content. At any rate, the first two lectures and the chapters are easy to understand and easy to read. At a minimum, you should listen to the lectures. I start with a very short repetition of what has been said in chapter 1 and 2 of UFA. On the upper pink area, we see the input elements here, which obviously go into the system. In the center of the input elements, we find the financial contract surrounded by the risk factors, which is the whole group here. Which are market conditions, counterparties, and behavior. Contracts are covenants two or more counterparties agree upon. Market are yield curves, FX rates, and any market condition acting on the contract. Counterparties are the description of the parties that enter the agreement, and behavior can be considered a catch-all category of the remaining risk factors that can influence the outcome. It's more than a catch-all category, but it's the easiest way to imagining it now. For more, you have to go into UFA. The distinction between financial contracts on one hand and the risk factors on the other hand is very important. In the contract we find everything that is certain, and there is only one thing certain in finance: the mutually agreed promise between the two counterparties. Everything else is more or less uncertain, even the keeping of the promise between the two counterparties. For this reason, these elements are called risk factors. So these are the risk factors, and this is certain. The risk factors might change at any time in an unforeseen manner. However, given a state of the risk factors, which means that these factors are set, so there is a market condition, there is counterparty information, and there is behavior, all is set. Given that, the expected state contingent cash flows depend solely on the agreement. So once this is given, so everything becomes a calculation which happens in here. Everything becomes deterministic or mechanical. They are deterministic because lawyers write financial contracts in a non-ambiguous manner. At least this is their intention, and in most cases they are successful. If they wouldn't be successful, our courts would be filled with disputing cases. There is another important distinction to be pointed out, the one between data and algorithms. At Actus, the focus is not on data alone, but equally on algorithms. Data means primarily input elements, which are interest rates, counterparty IDs, or contractual terms such as value date, principal, interest rate, interest payment cycles, and so on. It is obvious that no CEO or CFO or any other financially interested person would be very happy to look at such data alone. As we showed in the previous slide, financial reports are made up of what we call here analysis elements. Between the two layers lies a long series of deterministic steps. So we go down here. And these steps are algorithms. Because the way from a given state of the risk factors and definition of the contract to the final analysis elements is deterministic, the main task of Actus is to describe and program all these algorithms serving two purposes. First, we make an end to the endless reinvention of the wheel as it happens currently in the financial industry. Banks currently look at contracts as a heap of attributes, from where risk measures can be derived. We write the algorithms once for all. Being open source and well documented, everybody can see and understand the algorithms. The intention is to create a standard accepted by the industry, including regulators. This standard is necessary in order to perform systemic risk analysis. It will standardize financial contracts for the analytical use case. In this picture, the input elements rather represent data. That's the way the picture is drawn. Financial contracts, however, are also made up of algorithms, since the rules of the contract, which are programmed by Actus in form of contract types, can be represented by algorithms. Algorithms that turn the input elements into analysis elements. If I drew a line where data ends and algorithm starts, it would be here. The first set of algorithms produce what we call the contract events. So that is the first step. Let's call it Roman 1. We call them also cash flow drivers. And the second set, the analysis element. So that's from here then, once we have this line, the contract events which drive the cash flows. From here we have then a second step. Actually it goes in this direction and in this direction. Let's put that as second step, where we calculate the analysis elements, which then form the basis of all known financial reports and analysis. The main message here is, it is not about data only, but about data and algorithms, which have an equal weight at Actus. From all that has been said, the centrality of the position of the financial contract becomes quite obvious. The financial contract, with its data and algorithms to produce the contract event, is hub and spoke of the system. To understand the Actus approach, another important aspect has to be understood yet. Looking into the world of finance, it seems there exists an endless number of different financial contracts. If each financial contract were different, then we would need a different algorithm for each contract, and the task would become too large and unsolvable. However, a closer look into the real existing contracts reveals an astonishing uniformity between financial contracts, if we abstract from marketing and legal jargon aspects and focus on cash flow generation. Our current estimation is that the very vast majority of real existing contracts can be covered with a mere 30 different patterns. Taking what we have said so far, the task of Actus can be grouped under the four following headings. First, we define and specify the algorithms for 30 contract types. Second, we create a data dictionary for all necessary attributes. Third, we create a contract type dictionary where each contract type and everything surrounding the contract is described meticulously. Actually, this lecture is the first of this series. Fourth, we create a contract calculator on a website where it is possible to enter data and see immediately the results on the event level in tabular and graphical form. How do we know how good the model is or will be when we have the 30 contract types? What is the metric of a good model in this case? The model is good if we are able to recreate the state contingent cash flows found in the real world. How are we doing this? After completing the set of about 30 contract types, we will go into a model validation phase. The model is good if we can recreate closely the state contingent cash flows. In order to understand what this means, take this simple example. We are at analysis date AD0, T0 or AD0, and we have an instrument with exactly one cash flow at T1. The size is given by the error's length. The size of the cash flow and its time, T1, we get by asking the lawyer or the banker that created the contract. Now we model the exact same financial contract using our Actus contract types. We use the same states of the risk factors and we forecast the expected cash flow. If we get exactly the same cash flow at the same time T1 as this green arrow, we can say we are 100% precise. If we get the same cash flow but at a different point in time, then we make an error of delta t. Another situation would be a cash flow which is either too large or too small, as in this situation. Finally, we could have a situation where the timing and the size are off. So it's timing and size that defines the quality of the model. A simple quality measure is indicated by this square. A real contract, of course, has more than one cash flow, whereas this measure could be formed via a sum. There are different possibilities to solve the problem. However, the direction should be clear. This is a precision measure. Might not be the final one, but it goes in this direction. If we get a result of 1, then we know the model is precise. The further away we are from 1, it becomes less and less precise. After defining the precision measure, a next step would be to execute the validation. So first we would have to classify all existing financial contracts. That means speaking to many banks, to many practitioners. We would measure for each class the existing volume how many of these contracts exist and what is the notional. And then we would measure the precision of Actus versus real as we have shown in the previous measure. If we aggregate everything, we would come to this precision coverage ratio as we see it here in the graphic at the bottom. We see here at this point that 95% of all financial contract can be covered with nearly 100% precision. The further out we go, the precision drops. And the last percentage we might only reach with the 80% precision down here. Is this good? Is this bad? That depends on what we want. If we would say we want to have a 98% coverage at a 99% precision, then we have to go up here to this graph, see where this point is. It's about at 99%. So that would mean we are in. We would be satisfied. So we would accept a declining measure for the rest of all the contracts. However, if you would say we want to have a 99.5% coverage at a 99% precision, so if you would be out here, if you would like to have this point, then we would be out. This could be corrected, of course, by adding more financial contracts, which then shifts this thing out here. Something like that. Here. And we would be in again. Of course, a 99.5% coverage at the 99% precision is a very, very high measurement if you talk on the world level. But anyway, it depends. So we can add more contract types to reach that precision. Thank you for joining us, and we hope to see you in the next tutorial.